All right, good evening. It is September 15th, 2025, 18 years after one of the more spectacular days for me in my career when we got word that there had been an impact in the high plains of Peru. And every year since then, I've tried to commemorate this day with a talk of some sort, either in person public talks or online talks, to remind everyone of the danger that we face in, as many of my colleagues say, here on Earth in the cosmic shooting gallery. And so tonight I'm going to take you through a little bit of an adventure that happened back in the autumn of 2007 following the impact. And I'm going to get right underway. And if you happen to be watching live this evening and would like to put anything in the chat, I'll be happy to respond to your questions. And if you're watching this later and have any questions, do the same. Or you're also welcome to email me at geologist@gmail.com. That's GA is in the abbreviation for Georgia because that's where I'm at here in my home just outside of Atlanta. And so without further ado, I'm going to take us back to Saturday, September 15th, 2007. And we'll go back and take a look here. And the first thing that we're going to do is visit not Peru, but Canada. You see, on that weekend, back in September of 2007, many members, if not all members, of the impact cratering community were at a workshop in Montreal called Bridging the Gap. This was a meeting that brings together field geologists, modelers, experimentalists, for us to try to communicate about the processes of impact cratering. You might think that we all would be on the same page all the time, but I assure you that's not the case. And this was one of those years that we assembled to discuss impacts, and while we were there, word came through various sources, including media, that a potential impact had occurred in Peru. And what was really fascinating about that day was that many of our friends and colleagues throughout the community had pretty canned responses to the media. Either one, this was a hoax, or two, it was some sort of military test. Well, not all just dismissed it. Many wanted more information. And fortunately at the time, I was a student of an acclaimed impact geologist, Peter Schultz at Brown University. And Pete, he'll listen. And that day he listened, wanting more information. I remember sitting in a hotel room with him on the phone with a number of media agencies and scientists that were in South America. And from those conversations, we gained the opportunity, with an open mind, to visit the site. And we were invited by a Uruguayan astronomer and now good friend, Gonzalo Tancredi, along with his Peruvian colleague, Jose, with the Geophysical Institute in Lima. And they, along with other colleagues in Peru and surrounding areas of Bolivia, invited us to come down as soon as we could. It took a few weeks, but we were able to get together with a cinematographer, Ben, who you'll see from National Geographic, flew in from London. And we were able to find out what was going on in Peru, and it turned out to be quite a spectacular story. So if we, as I mentioned there, Gonzalo Tancredi on my right, me feeling rather tall there among my friends and colleagues, my former advisor, Pete Schultz, and then one of the Bolivian geologists, whose name unfortunately escapes me these many years later, there, who had arrived on the scene very early after the impact and was showing us what he had found there in the field. Behind us, you can already see these blocks of material, and those are part of the ejecta field from this crater that we now call Carancas. And before heading out to the crater, though, we were warmly treated in the city of Lima, there on the coast of Peru. And before, after a very long overnight flight from Miami, we arrived and immediately were whisked away to a home to take a look at some of the meteorite fragments that had been recovered. But along the way, we also were invited by Jose there with the Geophysical Institute to visit their headquarters. And there you see Ben with the National Geographic at one of the rare moments without his large camera. And being geologists, this was fascinating for all of us as we went into the Geophysical Institute and saw what Peruvians worry about most of the time, which are earthquakes. And we saw the board there showing the entire country and different recording stations and the latest earthquake activity. It turned out that while we were there in the center, that there was an offshore quake that I believe was in the moderate range, somewhere around 4 to 5 in magnitude. So we got the grand tour of the facility again before really getting to take a look at the meteorite for the first time. And one of our good Argentine friends, Maria Varela, she had already started doing the petrography on the meteorite, and we got to see this grayish mass already sort of rusting there. And there under the microscope, you can actually see the rounded chondrules. I'm going to try to get a little bit of a highlighter here for you, and we'll see if we can do that. And let's see if I can just get that up here for you. And we'll be able to see here these rounded objects that almost look like they have feathers in them. This is some very rapid quenching of droplets of melt very early in the history of our solar system. This is where the name chondrite comes from, composed of these chondrules. And this turned out to be a type of ordinary chondrite, a stony meteorite, that had many of these chondrules pretty well preserved, but also a number degraded, and that gives us what's called a metamorphic grade of 4 to 5. The H stands for high metal, which you really can't count on looking at these and saying, wow, that has a lot of metal to call it high metal. There's actually some fairly sophisticated geochemistry that has to be done to classify these objects. But it turned out to be an ordinary chondrite, an H45, and meaning it's one of the most common objects to hit our planet. But this one, of course, was special because, at least from what we had been told, the pictures we had seen, it had left behind a small actual impact crater. And so as we saw this in the lab, we were still very anxious to get out to see what all of the news reports had said was real. We really wanted to see for ourselves. To do that, we were almost immediately put on an airplane to go up to elevation. The village of Caracas is over 4,000 meters, up more than 14,000 feet above sea level. And again, we really didn't have much of a break between the flight from Miami, getting off the plane in Lima, being whisked away to the Geophysical Institute, whisked over to see the meteorite, and now we're on a plane headed up to, ultimately, kind of our first time to get to rest, the town of Puno. So to do that, we landed at a couple of small airports, including one at Cusco that many people on their way to the Machu Picchu know well. And our last landing was in Juliaca that you just saw, and then a rather long drive that we had to Puno. And we finally, as I mentioned, got to rest here on the shores of Lake Titicaca on the border between Peru and Bolivia. And as you see in this view, we ultimately had to make our way down to the town of Desaguadero, right on the Bolivian border, so that we could then find entry into the village area here of Caracas, very close to the southern border. As this was not my first time in South America, but my first time in Peru, and in the high Andean plains, this was quite a treat. Again, as a geologist, you get to look around and not only see the wonderful lake, but see the tectonic terrain, the result of plates colliding there to create the Andean mountains, and also there are volcanoes there. Number of stratovolcanoes that we could see. I was able to collect actual andesites, the intermediate volcanic rocks from the actual Andes, which was really special to do for the first time. The town there of Puno is steeped in history, and we were able to spend a little bit of time looking around town and visiting one of the cathedrals. But we were still, at this point, quite quite tired, and were ready to retire to our hotel. But before we were able to fully enjoy our rest, we were told that we had an audience with some professors with the local university. And so we followed our colleagues, and along with the dean of the university, who had met us earlier, out onto the streets of Puno to have dinner. And we thought we were having dinner, and then finally would be able to return to our hotel for a very, very overdue sleep. But on the way to dinner, I kid you not, we were walking along the street and noticed, we noticed later, we didn't notice at the time, that there was a sort of a garage door here, and then a tiny door inside of that garage door. And as we walked along this avenue, we suddenly were met with this door opening, a crowd surrounding us, and being pushed inside that door. For someone kind of on the tall side, I was pushed down and through into darkness. And when I say darkness, I mean darkness. When we were on the other side of that, we were in a pitch black room. It was startling. I will be honest. We looked at each other as best we could in the dark, and we kept asking our host, the leader of our expedition, Gonzalo, if he could, tell us what was going on from the Spanish that was being spoken. And even he really had no clue as to what we were experiencing, and we thought that we might be at our end. But it turns out that we were just special guests. It would have been nice to know that up front. But this was the sort of back secret entrance into the government buildings, where here late at night, still working in his office, was the governor of Puno province. And here you see Gonzalo and Pete and Jose, here the dean of the local university, and the minister of the interior for the Puno, here over on the left. But we had to be whisked into this building through the secret entrance, just because that is the security that the governor maintains. So after being sort of shuttled from one office to another, after about half an hour, a large corner of a very high ceiling room opened up. We were taken through the corner of the office and into a cabinet room, where then we met the governor and had a very nice conversation about the crater and about the local government's hopes that they might be able to preserve it and turn it into some sort of museum. Unfortunately, that part has not come to fruition over the 18 years. After that, we thought finally we were on our way to dinner and sleep, but we had one last completely off-the-grid stop. And that was at the local university. We were whisked into a studio. I mean, we're at 11 o'clock at night here, and we were taken into a studio on the college campus and asked to actually be interviewed by the young anchors in training here that you see. And Pete and I don't really speak Spanish, but fortunately Gonzalo did, and Jose. And so we were questioned about meteors and impacts and our interest in the Carancas event, and had really a very nice time before finally being able to get a very late night meal and get back to the hotel, the Plaza Mayor, as you see there, in order to rest. One of the things here with the very high altitude, of course, is the fear of altitude sickness. And if you've ever traveled in this part of the world, you might be aware that one of the indigenous people's remedies for altitude sickness is making tea or chewing on the leaves of the cocoa plant. Look, there's no cocaine in there. It's just the chemicals that are in the leaves do help alleviate some of the headaches from the altitude, and most of the businesses and hotels will have the facilities to make tea from those leaves to help out with the altitude acclimation, really, if you're going to be there. And we had still some driving to do from Puno. We were in a Land Cruiser, and me being the junior scientist in the bunch, I suppose, although still the kind of the largest member of our expedition, I was shoved into the back of our Land Cruiser with all the camera equipment, and I really volunteered for it. It was not a bad ride at all, but I got to look out the back window there and take photos as we went, and looking out over this magnificent Andean terrain and the view of the lake here, Titicaca. You see these cages out in the water. This is part of their aquaculture of raising trout that became a staple meal for us during our stay in Peru. At the end of that drive was the city of Desaguadero, and as we looked around the city here, we were get to see the incredible popcorn, or really pop maize. We were treated extremely well, and the hospitality of the largely indigenous Amara people was incredible. Our main task here, other than having a place to stay, and you see there our very humble lodging in a local hostel for mine and Pete's room there. Our main goal here was to talk to people who had seen the meteor come in across the sky. We had reports of a school kid on the schoolyard taking photos of the trail of vapor that was left in the sky. This did enter in midday on that Saturday, September 15th, and we also heard that there might be other people who had photos and different experiences to relate. Even the manager of our hostel had watched the inbound meteor from the roof of that hostel, and so we were able to interview him for the National Geographic program. And this shows you a aerial view of Desaguadero, and if I remember correctly, our hostel was one of the yellow buildings over here in the center of town. But you may be able to make out the schoolyard. There's a blue building here, I believe, right in this area, and this is the view off to the south that the young gentleman at the school had. And we were able to see some of the little, almost like corkscrew-shaped wisp, almost like a contrail in the air. And ultimately, our journey, though, would take us beyond the mountains there over into the village of Carancas. And we had to spend an entire day here in Desaguadero waiting for that morning we could get up and actually go to the crater. And it was really just... the anticipation was palpable with Pete and I. We really wanted to lay eyes on this crater to see that it really had been created by an impact, and more just than created by the impact of a meteorite, that it had been excavated by a shock wave. Because if it had, this would be the smallest shockwave excavated crater that we had ever seen outside of the lab. So it was a very, very important day that was coming up. And just some scenes there as we approach the village of Caracas. Just a beautiful high sky up above 4,000 meters. And of course, there in Peru, the local people raise livestock with the llamas and the alpacas, and also a number of cattle that were in the area. And we also had our guard dog. Our guard dog took on special significance in the National Geographic filming, as we had to video our approach to the crater many times. If you've ever been involved in documentaries, nothing ever is one take. If you haven't been involved in making documentaries and you trusted everything you see on them, I hate to burst your bubble, but a lot of things are, well, it's not really staged, but you want to get the look right. And so every time that we had to back the vehicle up and come racing toward the crater, this dog would basically chase the vehicle. So if you ever get a chance to see the National Geographic production of this on the program Naked Science, you'll notice the dog chasing us toward the crater. And we finally were there at the crater, got out of the vehicle and looked and saw this. And I mean, the size of this in the photo, it doesn't do it justice. This is actually a rather large hole at more than 50 feet across. And immediately, as impact geologists, we start looking at the layers of material in the walls. That's going to tell us the processes that created this, and then all of the ejecta, the big blocks of material, and the fine powdery material lying around. It was just truly a magnificent moment to get there and lay eyes on this. This is a panoramic photo that Gonzalo took and that we've used in our many years ago in our academic paper in Meteoritics and Planetary Science. And it really gives you a stunning view here. Again, imagine this is 50 feet, more than 50 feet across. I'm in the background here for scale. And we'll mention again the shed out here. There's a hole in that metal roof from material that was ejected from this site, launched out going fast enough to be able to punch a hole in that material. You'll also notice the big challenge for preserving this, why they really ultimately were not able to have a museum built around this site, is this is really a stream channel here. In arid environments, this is called an arroyo. In wet seasons, it will be full of water. In moderately wet seasons, you may have flash floods, but even in dry seasons, this tells you where beneath the surface you're likely to find water following that same course. And indeed, that's what we have here, where the crater forming event punched through the water table and left this giant mud puddle. And I kept wanting to actually see really how deep that was. Even offered to put a rope around me and venture into the center. But for some reason, Gonzalo and Pete just wouldn't let me do it. I still kind of regret that moment of really wished I'd been able to go out and really explore the very center of it. But interestingly, this structure is still there today. It's not as large. It's deeply eroded. But the basic compressed structure of these soils is still there. And that, no pun intended, still shocks us a bit that it has survived as long as it has. But that tells you something about the deep structure of this material and the fact that it really was compressed by a hypervelocity shock wave. And that's important to those of us who do work on these types of craters. The other thing here that you might notice is some of the locals still kind of standing guard, and the fence that have put around this. Very early on, there were a number of internationally renowned meteorite collectors who arrived very fast And they're rather notorious stories about some of their escapades while they were there. But ultimately, many of the meteorite fragments had been removed by the time we were there. There were still plenty of small pieces to be found, but ultimately what was really important were not the pieces of the meteorite that you could see in your hand, but the pieces that had been destroyed by this collision and disseminated through these sediments just as fine powder and sand. So what damage did it do other than putting a hole in the ground? Well, you notice that, first of all, that water that I just showed you. As people arrived, there were reports of sickness. We weren't sure whether to really trust those. Even when we were talking with people and interviewing them there were a lot of different stories about how sick or how not very sick people got. But after talking with everyone, we sort of agreed with a general conclusion that what really was poisoning the air, so to speak, that gave noxious fumes that some people were sensitive to, was really the organic matter that had been released from the soils underneath that arroyo, or in that arroyo. It punched through, and the water table suddenly was exposed there with these very organic, rich sediments, and a lot of those oxidizing very quickly produced noxious fumes. There might have also been some of the iron sulfide that was in the meteor itself that when it was basically submerged in that water, those iron sulfides could break down to sulfuric acid and sulfur dioxide and hydrogen sulfide very quickly. And SO2 and HS, hydrogen sulfide, are those things that give us a distinct rotten egg smell for a reason. We back off of them because they, if we kept breathing them, they're actually poisonous to us. So those two things combined, the breakdown of the sulfide minerals in the meteorite, along with the release of organic material from the buried soils, those likely made things a little tough on the air to breathe immediately after the impact, but that very quickly went away. What really was a little bit more of a lasting effect of this was the hole put in the roof of the shed about a football field away. There was a bull that reportedly was knocked over and broke a horn in the process before scampering away. And there was a gentleman who was downrange of the impact, a couple of football fields away, actually more like 3 football fields away, and was able to observe this impact, but much more close to the impact, about a football field away, 100 meters, was this gentleman. And he was on the uprange side, and there's a possibility that if he had been on the downrange side, which was around here to the southwest, that he may have had a very different experience other than just getting kind of slammed with dirt and slammed by the shock wave going through the air. But he probably would have been okay, but he may have been a little bit more banged up. But on the side of he was viewing from, with basically the impactor coming in over his shoulder, he got to see something that pretty much none of us have ever seen. I mean, no one has been recorded seeing the actual impact of a crater-forming event. And talking with him, it was really fascinating, some of the things that he could report that we'd only ever seen in labs, like an actual vortex of material going up the center of the center of the column of debris, in addition to this sort of curtain coming out at him. And he did not get knocked down. He did say that the pressure wave going through the air did make it feel like someone had put an anvil on his chest. And he said that he was disoriented for about 20 minutes. And I would imagine so, given what that extreme sudden change in pressure would have done to his inner ear. It had to be quite unsettling. And we were surprised that he had his hearing fully intact, but some calculations about the overpressure of that wave indicated that he was probably right underneath the limit of what was going to be safe without any permanent damage. So quite a tale that this gentleman had. And of all the people in that village that we met, he had to be the one to be closest to a meteorite impact, right? I mean, this is he was the sort of the evil Knievel of the village, and we had to chase him down on his bike in order to interview him. So when we got to our scientific study, really important was coming up here to the wall, as I mentioned before, of this crater, and looking at this zone here in yellow. And this is a hinge. This is the part of the structure where we actually had a material that was uplifted and overturned. As far as we know, there are only a few processes that can uplift the crust of the earth. Nuclear weapons, steam detonations, which are mass types of volcanoes that just flash water to steam and explode. Those can raise the crust up and impacts. But of those, only nuclear weapons and impacts can actually take that material, move it up, and turn it over. And so what we saw here was a clear hinge line with that overturn. And you can imagine underneath this, all of this soil, this is the soil that was here, flipped upside down, and there's actually grass upside down meeting the grass standing right side up at the contact between the overturned flap and the pre-existing surface. We also got to look through the ejecta blanket there for some of the meteorites, find some of our own, and they were tiny. This was a one piece that you see that kind of typical gray, and the sulfides weather very fast. They're exposed to that water. I mean, it did not take very long at all because of the water table, and I'm unlikely when this stuff came out, there was some of that water splashing with it. The sulfides were in really bad shape. The iron nickel metal that also exists in this type of meteorite was a little bit more pristine. You see some of that in a electron microscope image here of the kamacite. That's iron, largely iron, but then nickel with it alloy. Different things here like olivine and pyroxene that are magnesium iron silicates. And then the troilite is bright here, and that is the iron sulfide. Here's one of the chondrules, so you see what it looks like in the electron microscope. And then here we see a reflected light image of some of the kamacite and these stress bands going through it. Now those could have existed in the original asteroid and been part of that, but some of these started to look like they might have been formed as a result of the actual encounter and the shock that the object felt during the collision with Earth. And here's a little bit of the material attached to a magnet. But I was really interested in these ejecta blocks and the fine powdery material around the crater. And this is a large block of soil that, again, is just overturned. Again, the grass contact here. This is just fine soil that and sediment here. And you would find patches in it that look like this, that were just grayish material. It's like, okay, is that a piece of the meteorite, or what is that? And it turns out that it is meteorite material, but it's meteorite material that was instantly on, we believe, in the contact, in the impact, just shattered and pulverized and down to just powder and sand. And it's preserved in these blocks of soil many times deep inside of them. Like, I could dig down in the middle of this and still find patches like this. And I had a student in a class one time who I asked to do a little project for class where they had took an 8-ounce cup, 8 ounces of this sediment, and they meticulously went through it under a microscope and picked out all of the little sand-sized pieces of the meteorite. And there were thousands and thousands of these just in 8 ounces. So for an object that we actually ended up estimating was between 3 and 6 feet across, about 1 to 2 meters. Most of that material, we think, on this actual hypervelocity collision just pulverized. And in larger impacts, asteroids traveling even faster, up to 20, 25 kilometers per second, much of the material vaporizes. Not all of it, but most of it, essentially turned into atoms. So for this relatively low speed, traveling at about 5 kilometers per second, we don't expect everything to be atomized, but we would find some surviving members of the meteorite. But what was really weird was that sort of in between this. What happened to most of the mass? It wasn't in the bottom of the crater. You couldn't dig down and find it as a big lump to haul off to the museum. But instead, you really had this material just absolutely decimated. And it seems to have moved through the sediment, just like percolating through a coffee filter. And so this was a really fascinating find, helping explain where a lot of that material ultimately went. And some of it was ejected quite far away and combined with the local sediment to create little tiny impact brushes. I spent a lot of time at larger craters and ejecta looking at big samples of melt glass that is rolled up and combined with local soils and sediments. But here, these were little tiny fragments of melt that often were just amalgamations or molten pieces of the actual impactor. Usually the melted material is all earth material with a little bit of impactor maybe as dust grains inside, but here this is were molten pieces of the impactor, partially molten, that had combined together with both molten and not molten material from the ground and formed little clumps and balls that were then ejected. In some cases, finding them more than 50 meters, as you see here, away from the rim of the crater. And so these, this told us something else about the energy in this event, and that this really was a real impact event, not just something punching a hole in the ground. But I spent a lot of my time looking for mineral evidence of shock waves traveling through rocks. And so I often look for what many people know as shock quartz. And this is a shock quartz grain from the KT, or now the Cretaceous Paleogene boundary, the KPG boundary, from the Raton Basin in Colorado. This sand grain actually flew from the Yucatan Peninsula in Mexico 66 million years ago. But being hit by the shock wave of this giant asteroid that killed off the dinosaurs, it formed these lines that are actually little tiny zones of disordered silica in the quartz. Maybe you want to say glass. It's a little different than glass, but these are just zones where you destroyed the crystal lattice. And we found at Carancas some grains of quartz that had the same type of deformation, the same type of damage. And somebody might say, well, gee, out in there in the sediment, could you just, maybe find shock grains from other impacts? Well, maybe. Although it would be pretty rare, almost to the odds of being zero. But what was more important about these shock grains that I found was that they only occurred in really one area of the ejecta, and that was right at the point where the overturned flap, the top of it, met the pre-impact surface. So pretty much right where, just right at that material that would have been most highly shocked, right at the center of the small impact, that would have been the only place you really had the opportunity to shock the material. And so that material came out and was moving, and then sort of got trapped underneath this overturned blanket of material there on the rim. When we looked in other areas around this crater, looked in other areas of the ejecta, the pre-impact surface, you didn't find these. But right at that place where you would expect them to be, if they're going to be trapped, this is where we found them. So they're pretty confident that this is the shock features here are a result of this impact and not just inherited. And so additional evidence of the energy involved in this impact were provided by geophysical instruments. A lot of this was accessed by Gonzalo, along with a colleague with Western Ontario University, Peter Brown, looking at both seismic information, earthquake energy, and what we call infrasound energy. That is, energy traveling from something breaking apart and the blast wave going through the air. And both of those signatures together indicated not only a very energetic collision with the ground, something that would have been the equivalent of at least several tons of TNT, but also it indicated that it had broken apart once or twice up before it hit the surface. So you think, I mean, that's what's supposed to happen to an object a few feet across, or maybe up to 6 feet across, coming into Earth's atmosphere. It's under such dynamic stress at high speeds that it breaks apart. Well, if it broke apart, then why didn't it just rain down as meteorites and not actually create a shock wave in the ground? And the answer to that, well, we think we have a pretty good idea. It turned out that some previous experiments that Pete had done with the NASA Ames vertical gun at Ames Research Center in California had shown that if you take meteorite material, very weak, friable material, and launch it at very, very high velocities at a plate, so it would damage the plate it hits. Sometimes when you launch this friable material, it immediately breaks apart and spreads out, like you see here, into all these individual cones. These are shock waves coming off of these particles, still traveling at very high velocity. But you can see breaking apart. This, if it hits a plate, is just going to punch a lot of little holes or dents in the plate. But every so often, every few times the experiment was run, rather than breaking apart and flying off into this whole, very spread out flock, if you will, seeing the geese here below, instead, the pieces stayed together like a flock of geese, with a big leader there at the front, where you had a large piece out in the lead, and the shock wave off of that, going through the air, collected the smaller pieces back in its wake. And so by the time it hit, it punched a big hole in the plate. We think that may be what happened at Copernicus, and could actually happen with any number of impacts that occur on our planet. So this is a real risk from really small objects that otherwise we would expect it to just break apart and fall as meteorites. Some of our colleagues, though, wanted to question us about, well, this isn't possible. I mean, this is a one-off thing. How could this really happen? Some of them insisted that this was what's called a penetration pit, that this ton object just came in and slammed into the surface and punched a hole in the ground rather than a shock wave compressing the ground and excavating this crater. But we know for an object the size that is estimated for this event, from the energy, from the shock, all of those parameters, we know what would happen if a 1 to 2 meter size object comes in at basically subsonic, sub-hypervelocity anyway, speeds, and just punches a hole in the ground. That happened in 1976 with a similar type of a meteorite in China. And the 2 meter object came in, slammed, and buried itself something like 8 feet underground. And it was a multi-ton object there, a couple tons, and it was taken off. It was extracted and taken off to a museum. Well, there's no buried mass here to take off to a museum. There just isn't. And if there was, look at the size of the hole. Here's a 2 meter size meteorite punching a 2 meter size hole that went then buried itself 8 feet down. If this is a punched hole, this isn't a 2 meter object. This is a 15 meter object that has buried itself, and trust me, that would have been easy to find. So this was clearly a hypervelocity impact that destroyed much of the impactor and excavated this beautiful crater there in the Peruvian Altiplano. And so that brings us to the risk. As we look around our Earth, there are almost 200 or so confirmed asteroid or comet impact structures on our planet. And these are large, most of them. some are tiny, but this was a special case because those that are tiny in this view, and the orange and the yellows you see are ones that where there's pretty good evidence, but it haven't been officially confirmed yet as asteroid impact craters. Although this is a little dated, so there are a few that have now been confirmed. When we look at the really, really tiny ones often are created by iron impactors. Meteor crater is huge compared to, it's actually tiny in the grand scheme of things, but it's huge compared to Copernicus at, kilometer scale. So the object that created Meteor crater we estimate to be not 2 meters across, but 30 meters across, 30 to 40 meters across. And so the, even that was created by an iron impactor, something that was really strong material that could hold together in the dynamic stresses coming through Earth's atmosphere and still make a small crater. This was a stony meteorite and that hit Copernicus, and it was something that was not just stony, but it already had internal fractures and weathering products inside. So there wasn't a whole lot holding this together, which is probably why it broke up pretty easily there according to the infrasound data. And it really just was a matter of getting that lead piece out in front, shepherding everything back together. And how often could that happen? We don't know, but it's certainly something that is very plausible and did happen at a pretty regular rate in the experiments that Pete did with the NASA gun. So no one's stopping these, not to scare anyone, but no one's stopping these 1 to 2 meter objects coming in and doing this kind of damage. It's just more of a being aware that this is a possibility, being aware that in the event that this happened in a populated area, that this could be a natural event, not some military test, not some hoax, as people originally thought for this one. And so that's really important for our government leaders, our politicians to know, because quite frankly, in talking with some of the people there in the village, they thought that there was a chance that a neighboring nation had fired a missile at them. We had no idea there was those kind of tensions, but, apparently there were at the time. So it wasn't out of the realm of possibility. But, of course, this was a natural event. No one was firing a missile. But if you didn't know that, you could end up making some very rash decisions very quickly based on the idea that it could be a man-made event. So it's very important to realize this is a risk. It is something to look for. It is possible. And it's just a small reminder of the much larger, shooting gallery that we are in here on our Earth as it goes around the sun and our solar system. And so it really is a big deal. And that's where I want to stop tonight, because this is as our Apollo astronaut Rusty Swaggart is very fond of saying, impacts are the one natural disaster that we actually can prevent, that we can't not just mitigate against, but really take action against. The DART mission a few years ago was really instrumental in showing that we can move asteroids, potentially, if we need to, although we're a long way away from being able to move a big one if we knew one was coming. So that's why I remind everyone every year of this event, because it's different. And it also didn't get a lot of press coverage, we think, because, well, think about it. A very tiny object falling out of space and creating creating this type of damage. That's something that we could do from orbiting platforms, from satellites. And so this was a little bit of a blueprint for some of those people involved in military applications. And so there were those out there that really kind of wanted the details of this to stay in the academic journals and not out there. But today, many years later, a number of nations around the world have declassified what were called kinetic impactors, that they have the ability to actually launch small objects, meter size, cylinders made of very robust metals, from orbit down to the Earth's surface. So this is kind of nature's version of that. And it was very fun to study, and I really hope that if you're watching this, that you help me pass this along, the story of Copernicus, to anyone interested in science and anyone interested in impacts and meteorites. And I appreciate those of you watching either live this evening or recorded later. And I also want to announce that, as some of you know me, I have been previously in various ways the host of the At-Home Planetarium show that I broadcast online for a number of years. And here with this YouTube channel that I'm calling Southern Space Rocks, I'm relaunching that online planetarium show, the At-Home Planetarium show, and we look forward to bringing you content here in coming days and weeks. And I will post a schedule of that here on this YouTube channel for you. And so again, thank you very much for helping me celebrate this very special moment in Earth's history back on September 15th of 2007 with the Copernicus impact. I hope all of you have a fantastic remainder of your week, and good night.